All right. Hello, everyone. Welcome to Women Who Code San Diego's Algorithms Interview Prep. Let's get started. So today we're going to learn about BigO strings and arrays. Sorry, I'm not on the title slide right now. But before we get started into the nitty-gritty details of today's topic, I do want to go over tech interviews if you don't have the experience doing that already. So a tech interview, a technical interview, when you're doing one, they want to figure out three things. First, how good are you at problem solving? What they're going to do is they're going to give you an algorithm, and your job is to figure out how to, or they're going to give you an algorithm challenge, and your job is to figure out an algorithm that will solve that challenge. And the first thing they want to figure out is, can you do it? Can you solve this challenge? The second thing they want to figure out is, how efficient are you at doing this challenge? And that's what we're going to talk about today when we're talking about time and space complexity. How efficient is your algorithm? And then finally, if you're doing a live interview or an in-person interview with a whiteboard, they want to figure out, how good is your communication? What are your communication skills like? Do you take hints when they give them to you? Are you positive and upbeat? Like, what are you like as a potential coworker? And so those are the things that you want to think about when you're practicing your technical interview skills. So here's how this series will help. We are big believers in the mantra that practice makes competent. Maybe not perfect, but competent. And so what this series will do is that it will give you the skills you need to be successful. Like, we're going to give you the information you need, but we're also going to give you the space so that you can practice. And so what we're going to do is we're going to meet twice a month. The first lecture will be about, the first meetup will be a lecture. And then the second one will be a practice section that goes over what we learned in the last lecture. Okay, so now let's go over tech interview principles, or what to do when you don't know what to do. So the thing about technical interviews is they can be pretty stressful. They can be kind of nerve-wracking. And often what will happen is maybe you'll go into an algorithm challenge and you're just like, I don't know what to do. Like, I can't think. I'm so stressed. Oh, what do I do? And the thing is, first, just take a few breaths, calm down, and realize it's okay. Like, you don't have to be the most amazing, perfect person, but you can do certain things, certain principles that will get you as close as possible to the most optimal answer, if not the most optimal answer. So don't worry, freezing happens. It happens to all of us. It happens to me. Sometimes it's a little bit stressful, but it's okay. Just remember your principles and go through them step by step. And that's going to help you get to the most optimal answer. And what are these principles? Cbop. So we have this little device here called Cbop. Cbop is our cute little corgi. And whenever you're feeling very stressed out, just remember, Cbop is with you. Cbop is here to get you to the finish line. And what does Cbop tell you to do? Cbop tells you to first clarify the question, then work on concrete examples, then design a brute force solution, then think out loud on ways to optimize that solution, and then apply certain patterns and data structures. Okay, so what does that mean? So first, clarify the question. When you're given a challenge, whether it's an OA where you're by yourself or where you're actually with the interviewer, you want to ask yourself questions or ask the interviewer questions to make sure you actually understand the problem. Because let me tell you from experience, the worst thing you can do is go through an algorithm and design it, and at the end be like, wait, this isn't even answering the question that was asked. Like, I'm answering a problem, but not the one that was asked. So you really want to spend a lot of time up front making sure you understand the problem. So if your interviewer is there, you can ask them like, okay, so you want me to see if a string is a palindrome. So that means that you want me to figure out if the string is the same forwards as backwards, right? Okay, so what should I be returning here? Okay, is there a certain time and space complexity like limit here? Like just ask the questions like, okay, you want me to, am I gonna get integers? Am I gonna get strings? Like what's happening here? And ask a bunch of questions so that you can fully understand the challenge. Also, work on concrete examples. Now, it's part of clarifying the questions, but I'm separating this because this is super important. You want to come up with your own test cases. The interviewer will give you test cases to help you solve the problem, but you want to come up with your own as well. And what this does is that it makes sure, A, that you fully understand the problem. So you can work through a test case and say like, okay, you want me to see if a string is a palindrome. So if I have the word CAR, that should return false, correct? Okay, what if I have race car? That should return true, correct? Like you want to come up with your own test cases and not just happy cases where it's clear, but maybe something like an edge case, like, okay, well, what if I get an empty string? What should I return here? Should that be true? What if I get one character? A string with only one character, is that true or is that false? Those are the questions that you should ask yourself and the interviewer as well. And the best part about examples is that once you do finally implement your algorithm, you can go through the test cases, all the test cases that you designed, and make sure that the expected output matches, or the actual output matches the expected output. And I know when we're all like LeetCoding and looking at hackery and stuff, it's very easy to just like write the algorithm and then just like shove it at the test cases and be like, okay, that failed. Let's recode it. Like don't do that. You want to review your own work and evaluate it and figure out why it's not matching the expected output. Don't just like try to game it as much as possible, because the thing is, okay, maybe it matches that test case, but maybe it doesn't match the hidden test case that the compiler has. So work through it yourself and figure out where in my code, like where in my logic is it not matching, or is it not delivering what I think it's supposed to be doing? Where is the behavior not matching the expected behavior? And then figure out from there. Okay, design a brute force solution. So the thing is, you're gonna have an idea, right? You're gonna be like, okay, just see if a string is a palindrome. Oh, one way I can do that is to maybe copy the string from backwards to forwards and make another string, and then go ahead and compare each character of the string to see if it's the same. That would be a brute force solution because it's not the most efficient solution. However, don't freak out that you don't have the most optimal solution, because what you're going to do is you're going to put it on paper, and then you're going to analyze it. You're going to think out loud, and you're going to ask yourself, is there a way that I can make this more optimal? So the act of copying each letter from backwards to forwards is O of n, and then iterating through it again is also O of n, and creating another string is also O of n space complexity. Is there a way that I can perhaps, instead of using extra space, do this in place? Or is there a way, instead of iterating it 2 times, that I can do it 1 time? And you know, the beautiful thing about designing a brute force solution first is that if you cannot come up with a more optimal solution, it is better to have something than nothing at all. You don't want to reach the end of an interview and be so caught up in figuring out the most optimal solution that you have nothing to show for it. So what you want to do is have a design, like your first most, I don't care if it's exponential, like if it's just crazy runtime, put something down and then think to yourself, okay, ask yourself the questions, how can I make this more optimal? And then go from there. And when I say design your brute force solution, I don't mean implement it in code. I mean like comment out what your your brute force solution is, like pseudocode it. And then if you cannot figure out the most optimal one, then just go ahead and implement your brute force one. But if you can, then figure out pseudocode your most optimal solution and then implement that. Okay, so I kind of talked about this, thinking out loud. So ask yourself the question, can I make this more optimal? Can I use less space? Can I use less time? And you want to ask these questions out loud, because what it's doing is that it's communicating to your interviewer like, hey, I'm thinking about these things. I'm asking like how I'm understanding that this is not the most optimal solution. And I'm asking ways on how to get that better. Like that is a sign of a great engineer, because you're asking yourself these questions. And another thing is, if you get stuck, your interviewer knows where to help you. Like if you're going down some path, but you're thinking about it out loud, your interviewer is like, hey, I see where you're going. You don't want to do that. Try thinking about this instead. But if you're completely silent and super in your head, it's not going to help your interviewers see where they can help you. Now, sometimes I totally get it. Sometimes you need a moment to think to yourself, because like everything can be pretty distracting, especially when you're stressed. That's totally fine. Just say to your interviewer, like, hey, I just need a quick second just to think about this just for a little bit. And then like, let's get back. That's totally fine. But don't spend the whole interview in silence. Tell your interviewer like what's going on in your head. Okay. And then last but not least, apply patterns. So when you're thinking about like your plan, ask yourself, okay, is there a good data structure that can work with this? Like, hey, I want to see if something is a palindrome. What if I put all of the strings in a stack, and then I popped the stack, and then I was like, hey, do you match? That could be a good way to use a data structure. Not the most efficient, but it's a good use of a data structure. Or you can look through your toolbox of algorithm techniques. Throughout this series, we're going to give you different algorithm techniques that you can keep in your back pocket or your toolbox. And what you want to do is you want to rummage through your toolbox and see like, is this something that can work? Like, is this something that could use a two-pointer technique? It is, and that's the most optimal solution. Is this something that is divide and conquer? Or is it, recursion? Like what do I have in this toolbox that I can use that could make me solve this problem in the most effective manner? So that is Cbop. Cbop is your friend. Look at Cbop. Cbop's saying hello. Remember, when you're in your interview, you want to clarify, work on examples, design a brute force solution, think out loud, and then apply patterns and data structures. So now that we've got that all covered, let's talk about BigO. Let's see, how am I doing on time? I'm doing all right, a little bit over, but we can keep going. Okay, so BigO, what is BigO? BigO is basically a tool that we use in computer science where we describe how efficient an algorithm is, meaning as I get this data size or data input, and I increase the size of this data input, how many more operations does it take to process this data? So when I say things like, can I do better? I've got this brute force solution. Can I make it more optimal? This is what I mean. That BigO tells you how efficient your algorithm is. So if your efficiency is like O of 2 of n, which is exponential, that means it's super inefficient. But if you're like O of 1, where it's constant, that's very efficient. So these are the things that you want to think about when you are looking at your algorithms. It's also called time complexity and space complexity. And the n that is used in O of n, O of n squared, over that is the size of the data input. Typically, it's the size of the data input. Okay, so here are some common growth orders. And this handy little graph tells you basically how good or bad they are. So all the way at the bottom in the green area, we've got the best of the best. And this is constant, which basically means that no matter how big your input size is or your data size is, it takes the same number of operations no matter what. And then we've got logarithmic, which is like, hey, your input size is growing and your number of operations is growing, but it's only growing by a little bit, which is pretty darn good. Then you've got something like O of n, which is linear, which basically means like, hey, your operations grows in direct proportion to the size of the data input. So if you, a lot of times you'll see this if you have to iterate through every single element in an array. And so if you double the size of the array, then you double the size of the operations. It grows in direct input to the size of direct proportion to the size of the input. Whew. Okay, in the middle, it's called bad, but I think it's like, meh, it's not desirable. And that's something like linear arithmetic or O(n) log n. And basically what that means, it's kind of like a combination between O of n and O of log n. And basically it's like, hey, I'm iterating through every element in the array. And then also I am performing a log n operation. Then you have O(n) squared, and this is where it kind of gets a little iffy here. And that's kind of like linear, where it grows in direct proportion. But as you iterate through every single element in the array, you're iterating through every single element in the array again. So that is polynomial, very slow. And this is where it starts to get real sketch. And this is exponential and factorial. At this point, I'm just going to say, if you're over here in this range, you want to do whatever you can to make your algorithm as efficient as possible, because we're talking like, if you have an exponential time and you've got like an input size of like 1 million, I don't even know if you're going to be alive when your algorithm stops like computing, the answer. So you want to make that more efficient. And we're talking about small input sizes here, like 10,000, 1 million, whatever. Believe it or not, that is actually a very small input size. When you think about things like, like self-driving cars or computer games, all these things are taking up all this data. It needs to be processed, and it needs to be processed fast. Can you imagine playing like, a video game and it takes you 5 years to move to another point of the game? And so that's why we have to think of optimizing our algorithms, because when you increase the number of operations, it increases the time to process the data. Okay, so after I've done my whole spiel, now it's time for you to tell me what you already know. So here's what I'm going to do. I'm going to describe a function, and you are going to tell me in the chat what time complexity that function has. Oh, I see something in the chat. Oh, can I please repeat O(n) log n? Yeah. So O(n) log n is linear arithmetic. And basically what that is that it's typically where you iterate through every element in the data and then perform a logarithmic operation. So it's kind of a combination between linear and logarithmic, or you could be doing a logarithmic operation and then iterating through element of the array. We're going to talk about it a little bit more coming up, so don't you worry. Oops. Okay, let's test what you know. So this is an algorithm called insert at n. So what it's doing is that it's taking in a list of strings, and it's taking in a number n, and it is inserting the string hello world at the index n. Tell me in the chat, what is the time complexity of this function? All right, that's it. It is constant. And the reason why it's constant, let me go, whoops. Yay, it's constant. And the reason why it's constant is because that's just really how arrays work. It doesn't matter if your index is, 10, doesn't matter if it's 1,000, doesn't matter if it's a million. Inserting a value in an array takes the same number of operations every single time. So when you're looking to see if something is constant, you want to look for basically there's no loops that depend on input size, no recursion whatsoever, and no function calls that scale depending on the input size. So basically what constant means is that no matter how many operations, or excuse me, no matter the size of the data, no matter whether you increase it, double it, triple it, whatever, it's the same number of operations every single time. Quick note about Python. Python, if you use Python actually doesn't have what's called an array. They actually have lists. And that is, what that is it's actually an abstract data type, which is called a dynamic array. And so occasionally what you'll see is that when you're appending to your list using Python, the time all of a sudden, just like if you analyze the time, like if you actually like measure the time all of a sudden randomly will just increase out of nowhere. It's constant for most of it, but then all of a sudden it'll just increase out of nowhere. And that's because it's a dynamic array. And what it is doing is that as it has an array of a set size, it fills up the amount of the array. And then as you add another, or as you need to add another element that's greater than what the amount that has been allotted, it creates a new array that's double the original size. And then it goes through and it copies every element in the original array and it puts it in the new array. So it's just something to think about when you're using your list in Python. Like obviously, if you're doing an interview prep, still use lists, like it's the best, but it's just something to think about in the back of your head. And it might be a cool little fun fact that you can point out to your interviewer if you feel like it. Okay, so that is constant. All right, so let's go through another function here. So we have a function called sumList. And what it's doing is that it's taking in a list of integers and it's going through every value of the list up to n, and then adding it to the total, and then returning the total. What is the time complexity of this algorithm? All right, you already said it. It's linear. Yay, congratulations, 5 points. And the reason why is because the number of operations grows in direct proportion to the input size. So if you're adding all of the numbers up to 9, you're doing 9 operations. If you're doubling that and you're adding all the numbers up to 18, you're now doing 18 operations. It grows in direct proportion to the input size. Now, when you're looking for something that's linear, something you want to look for are loops that depend on the input size, which you saw here, right? This loop depends literally on n. You also want to look for things that are like for I in range n, basically something that's iterating through all of the values of the input size, automatically linear, at least. Okay, let's go through another one. We have sumList again. Hey, cool, looking at the same function, or are we? So we're going through the values of the array, but instead of doing I++ or going through each value, we're actually multiplying I by 2. So what is the time complexity of this function? Go ahead and drop your guesses in the chat. All right, so I see a lot of people saying linear. Can someone tell me why they said linear? No contenders. Okay, so I will go ahead and tell you it's actually logarithmic. And I will tell you why. I'm going to show you why it is logarithmic. Hoping that this works. Oh my gosh, I hope you see this. I practiced this morning. Please tell me you see it. Okay. So why is this logarithmic? Now, a lot of times when I ask this question, people are saying it's O of n over 2 because you're going through the values, but you're multiplying by 2, so you're just dividing by 2. So a lot of people are like, oh, well, it's probably O of n over 2, which is, O of n. Okay, well, one thing that I like to do whenever I'm not quite sure or whenever I want to check what the runtime is actually just count the number of operations and see how it increases as you increase n. So what we're going to do here is we're going to go through this and we're going to actually count through the number of operations and how it grows as we double the size of n. So no one actually said O of n over 2. That's why I paused for a second. So I'm going to go ahead and actually put O of n, like what it would be if it was O of n. So I'm going to just say 2, 4, 8, and 32, right? I did not write 2, 4, 8, 16, 32. Okay, cool. Okay, so let's count the number of operations. So n equals 2. So we're starting at I equals 1 and n equals 2. I is less than n, so we're going to go ahead and do an operation. This right here is a constant operation. So we're just going to say it takes 1 operation. And even if it was 5 operations, like say if we had total and then we times it by 2 and then added, I don't know, infinity, I have no idea. Even if that was the case, it's constant. So we're just going to treat it like 1 operation. So we did 1 operation. Now I times 2, so 1 times 2 is 2. That is not less than 2, so we're going to stop there. Okay. So already we know it's not O of n because it's less than that. Okay, so let's double the input size to 4. So n equals 4. I equals 1. 1 is less than 4, so we're going to do an operation. I times 2 is 2. 2 is less than 4, so we're going to do another operation. 2 times 2 is 4. 4 is not less than 4. And so we're going to stop, and that is 2 operations. Now, if you're thinking n over 2, if you're thinking O of n just iterating through 1 time, that's not the case. But if you're thinking O of n over 2, hey, you know what? So far, it looks like you're winning because it was 1 over here, it was 2 over here, and we're doing pretty good. I'm actually going to get rid of this because it already lost. Okay, but O of n over 2 is still a contender. Okay, now let's do it when n equals 8. So I starts off at 1. 1 is less than 8, so we do an operation. 1 times 2 is 2. 2 is less than 8, so we do another operation. 2 times 2 is 4. 4 is less than 8, so we do an operation. 4 times 2 is 8. 8 is not less than 8, so we stop there. Uh-oh. So we've got 3 operations here, and we've got 4 operations here. So this is looking like it's a little bit less than O n over 2. Okay, let's keep going. We're going to do 16. We start off at 1. 1 is less than 16, so we do an operation. 1 times 2 is 2. 2 is less than 16, so we do an operation. 2 times 2 is 4. 4 is less than 16, we do an operation. 4 times 2 is 8. 8 is less than 16, so we do an operation. 8 times 2 is 4, or it's not. 8 times 2 is 16, and we didn't, but 16 is not less than 16, so we don't do another operation. So take a look at here. We've doubled it multiple times, but the number of operations has increased just by a little bit. Okay, just to really drive this point home, I'm going to double n yet another time and see what happens to the number of operations. So we start off at 1. 1 is less than 32, so we do an operation. 1 times 2 is 2. 2 is less than 32. We do another operation. 2 times 2 is 4. 4 is less than 32. Do another operation. 4 times 2 is 8, which is less than 32. We do another operation. 8 times 2 is 16, which is less than 32. We do an operation. And 16 times 2 is 32, which is not less than 32. So we don't do any more operations. And take a look. We've doubled it yet again. And look at the number of operations. We're doing 5 operations. And in fact, if I were to look at this, 32, we've doubled it 5 times. And the input size is 32. And we're doing this we're only doing 5 operations. Oh my gosh, I said that so wrong. Anyways, the point I'm trying to make here is that this looks like a logarithmic algorithm, right? And that's one way you can find out whether or not your time complexity is a certain function. It's to literally just count it out. I don't recommend you doing that in an interview prep. I recommend you doing that practicing at home. The more you do this multiple times, it's going to drill in your head like, hey, this is a logarithmic algorithm here. But a couple of tips that will help you figure out whether or not it's logarithmic or linear is that you have a loop that's divided by a constant. So what we did right here, although it looks like we're multiplying by 2, what we're doing is we're actually dividing the counter. So what we're doing is essentially throwing away a whole section of the data. Or you have 2 pointers, I and j, that change by a constant. So like maybe I starts off here, and then j goes like 4 times this way. You're dividing the data set by 4. Or you're traversing through only half of a data structure, like binary trees. If you've ever done a binary search tree or worked with trees, if you're only going one side of the tree, you're throwing out all of that data. And so that means you're traversing it in a logarithmic fashion. So just trying to drive the point home here. Oh, how do we know that 5 is log 32? Just math. Honestly, if you keep doing this over and over, you just start to remember this. But if you, oh gosh, I swear, my math skills are pretty like trash right now these days. But oh, can you see this? Okay, so if you're trying to find the value of this, what you do is that you log it. And that's what's going to give you that value. So, oh, gosh, we're going to talk about this later because I don't have the time to go over it. But I swear I will come back and I will give you a better explanation than the explanation I was about to give you. But basically, it's just math and using logs. And as you keep doing this, like as you keep analyzing time, and as you keep like looking at it, you're going to remember, oh, log of this number is 5, or log of 32 is 5, or log of 8 is 3. You're just going to remember as you keep doing it. I'm sorry, that was not a great explanation, but I will come back later and I'm going to drop a better one in the chat of the event, I swear. Okay, so Linear arithmetic. So basically, this is a combination of O of n and O of log n, which essentially means that you're going to be doing an outer loop, that's O of n, and an inner loop, that's logarithmic. Or you're doing an outer loop that's logarithmic and an inner loop that is linear. So it's just a combination. Sorting algorithms usually do take O of n log n time. And at this point, I just assume if I'm going to sort something, it's going to be O of n log n. Like I don't even try to compute. I'm just saying, hey, I'm sorting this. So that's O of n log n. Polynomial, once again, similar to O of n, but instead of just iterating through the values of the array, you're iterating through it again. So like you're at 1, and then you iterate through the values of the array. Then you're at 2, then you iterate through the values of the array. And then once you compute all those operations, you've iterated through the array, and at each step, iterated through it again, and that is O of n squared time. Exponential, once again, if you're at exponential, please stop and figure out what you're doing to try to make this a little bit better. But exponential is basically, the easiest way for me to think about this is a recursive function that calls itself multiple times. And one classic example of this is the Fibonacci sequence. If you want to figure out what the number is at the nth spot in a Fibonacci sequence, all you have to do is figure out what it is, figure out what the previous number is, plus the 2 prior to that. And if you keep doing that over and over, you can call it recursively and figure it out. And that works for very small values, but when you do really huge values, like, I don't know, 1,000,000, you're not going to be alive for that computer to finish computing that. So that's why exponential is a really bad runtime. Okay, let's continue and talk about strings and arrays. I think we're good on time here. Okay, so I love arrays because they are the most simple data structure that you can possibly work with because they're built in. So an array is a collection of elements, usually of one data type, and they are referenced by index. So in this example here, we have an array of size 5, which means there are 5 elements in the array. And the first element of the array is not at the first index. It's actually at the 0th index because we start at 0. In computer science, we start at 0, 0-based indexing. So if you want to find the first index, you subtract by 1 and you get the 0 spot. If you want to get the 5th index, you can't go to, the 5th spot in the array because that's actually out of bounds. So you're going to go to the 4th spot. Arrays have 4 standard operations that are performed in constant time, no matter how big or small the size of the array is. And that is insert, to insert a value at an array, constant time. To retrieve a value from an array, like to get it, is constant time. To update, which means to change the value, constant time. And to find out the size of the array is also constant time. Now, strings are pretty cool. They're very similar to arrays, except they are a string of characters. So whether you've got hello world or the 6A5ACD or this huge sentence here with lots of white space and punctuation, those are all strings. It can be a letter, it can be numbers, it can be punctuation. All of those are characters. And when you string them together, you have a string. And just like arrays, strings are indexed starting at 0. So if you want to find the first character of the string, you want to go to the 0 index to find the capital letter A. Okay, finally, let's go through some techniques. Now, at the beginning of this lecture, we talked about your digital toolbox, right? Like what are the things that you can use that are going to make you successful in solving this algorithm? And one of the tools, your like little wrench here, one of the tools that you can use in your toolbox is the 2-pointer technique. I love this technique. It's awesome. It's great. It's a great one to use for strings and arrays if you can use them. So there's a lot of string and array problems that can be used or solved using the two-pointer technique. And your job as an interviewee is to find out which ones. So when we're looking at our algorithm, or when we're looking at the Cbop, and it says apply patterns, one of the patterns is, oops, I'm running out of battery here. One of the patterns is the two-pointer technique. Boop. Okay, and what is that? So two-pointer technique, literally what it is, it's in the name, right? You have 2 pointers and you're using these 2 pointers to move in various ways to process your data. So maybe you've got 2 pointers starting off at the beginning, or maybe they're both at the end, or maybe one's at the beginning and one's at the end, or maybe one's in the middle and one's also in the middle and they're going this way. Basically, you have 2 pointers and they are working in various ways to help you process the data in a more efficient manner. So what the heck does that mean? Let's go through a concrete example. So this problem says, hey, you're given a string. We want you to reverse all the characters in the string. Okay, what's the first thing that we do here? Type it in the chat. When you're given this problem, what is the first thing that you do to solve it? Ah! I just gave you the answer. Oh, but I didn't. Okay, this is actually a trick question. You actually want to enlist your friend Cbop. Enlist the help of your friend Cbop. So whenever you're doing an algorithm challenge, I know this is a trick question, but whenever you're doing an algorithm challenge, yes, it's important to think about all the things like, all right, my two-pointer technique, doing whatever, but actually you want to slow down, calm yourself, and really work through Cbop. So the things you want to ask are, got some things. Yes, I did trick you. Sorry, so sorry, kind of not. But what you want to do is ask yourself, okay, what is the problem trying to ask me here? All right, so it says I'm doing this here. Let's go ahead and do it to the iPad. Okay. Oh, is this showing? Okay, it's just a little bit slow. Okay, so it said to reverse the string, right? So you're like, okay, reverse a string. So some questions I have are, do I need to do that in place? It's a string. Will I always get the same? Will I always get a string that has characters? Like, what happens if it's empty? What should I be returning here? Let's see. Any other questions I have? I guess that's pretty much it. Oh, what if I have a character like this and I want to reverse it? That should just turn out to be that, right? Okay, those are the sort of questions that you should be asking. It's a string. Will I ever receive an input type that's not a string? Will all my strings will be valid? Okay, so now we have Cbop. I'm going to just write this down to help us. So that was clarify. Now let's go through some examples. Well, part of our clarification, we did go through some examples, but if it's an empty string, we're going to assume that it should just be an empty string. If this is ABC, we should be CBA. Let's do another one where it's kind of crazy. So A, B, C, D, E. Oh, A, B, C. Here we go. Space D, E. So that should be E, D, space CBA. Okay, so that should be cool. These are examples. So maybe our interviewer gave us this, but we went ahead and created these extra test cases to be very confident that it is giving us, or our code is giving us the expected output. Okay, B. Does anyone remember what B is? It's okay, I'm going to force. So design a brute force algorithm. Now, brute force algorithm, sometimes the brute force algorithm, if you've been doing this for quite some time, sometimes the brute force algorithm is a little bit harder to design than the optimal one if you've been doing this for a while. But, and in that case, don't like try to force that. But I'm going to try to see what the brute force algorithm would be to see if I can reverse it. Oh, okay, I know. So maybe I can do something like this where I have A, B, C, and I go to, I don't know, what the heck. I go here and then, oh, and then I move it over. Ooh. And then I go here and then I move it over. Uh-oh. And then I go, wait, that is not reversing it. Okay, I really don't know what the brute force would be for this one, but I'm going to go ahead and just go through the two-pointer technique. So now let's see, think out loud. Let's say we had a brute force version. I'm sorry, I probably should have figured out what the brute force version is before I started this. But let's say we had a brute force version and we thought, okay, well, this brute force version is giving me O of n squared complexity. Think out loud. Is there something I can do that can make it a little bit more optimal? Let me see what's going on in the chat here. There's a lot of chatter here. Oh, okay. We've got one. We can make a new string. What? Okay, I'm like trying to think that I think that's actually the most optimal solution. But okay, so I'm gonna ask myself, I'm gonna say, is there a way that I can do this that's a little bit more optimal here? And so what I can do is I can actually use two strings. So, or two pointers. So here I have A, B, C, D, E. What I can do is I can start with I, and then I can start with J, and then I can switch and iterate backwards and forwards simultaneously. So what I can do is, using my two pointers, I can take A and E and switch them. So whoop, whoop. And now I'm going to iterate here. Switch. Oops. Whoop, whoop. And then I'm going to iterate forward. And hey, they've met each other here. That means I'm done. I've just reversed a string, and I've only done that in O of n space complexity. Because when you think about it, if you're reversing a string, you have to go through each character. You have to visit each character. You can't like only go through half of the string and think that you're going to reverse it. Like that's not what it is. So you've went ahead and did it in O of n time complexity, which is pretty darn good. And so you're good to go here. So let's take a look at this. ABC, we've got I, J. Let's switch. Okay, and go forward. Whoops, get over here. All right, let's look at our test case. CBA, is that what the expected output is? It is. So we know that our algorithm is doing well. And then what you would do is you would go through each of your examples and make sure that your algorithm is producing the expected output that you had designed in your test cases. We don't have time to go through all of them right now, but that's what you want to do when you are evaluating your algorithm. I'm so embarrassed that I didn't think of the brute force solution, and definitely have to do that for next time. Okay, so this is the two-pointer technique, what we just went through. You have a pointer at the front, you have a pointer at the back, you swap and you iterate towards each other. And then once they meet, or once one goes over, once one passes the other, you know that your job is done. You don't want to iterate it through it twice. You just want to iterate through the data until they meet. And then that's when you know the job is done, and that's when you know that it's reversed. And this is what this would look like in Java. Something to note, I said O of n. Time complexity is actually around like O of n squared, because your one pointer isn't going through every single element. One pointer is actually going through half of it. But when we're using big O notation and you have a constant like the half, you drop the constant. So you disregard that, because as it gets super huge, those little constants don't really matter. Okay, so I've done a whole hour of talking, 50 minutes and 59 seconds of talking. And now it's time to implement what I just said, so you can really cement everything that you've learned here. So what we're going to do is we're going to put you into breakout rooms, and you're going to practice a problem using the techniques and the things that we talked about today, and try to solve the algorithm. Okay. Do I have an example of what this would look like in JavaScript? I do not. However, you can feel free to code it in JavaScript. We're pretty language agnostic here, so when you implement your code, you can use whatever you'd like. But the point being, so the implementation is just there to help you. I definitely recommend getting used to looking at other languages when you are examining code, because a lot of times, even though it's not the same syntax, it's a little bit similar. So basically what you're doing here, just to explain what the implementation is, you have a pointer called left, and it's at 0, and you have a pointer called right, which is the last index of the array. And so what you're doing is, as the left pointer is less than right, so making sure that they haven't met up or passed each other yet, you want to create a temporary variable, this is temp, that stores one value. Then you switch the values. So the plus plus, I guess that's the part that's a little bit annoying about Java, is that the plus plus and the minus minus might not translate for every language. I actually use Python myself. It's been a while since I've coded in Java. But basically what that's doing is you're going to hold a temporary value, and you're going to store one value, and then you're going to replace the other value with the temporary value. So the previous value with the temporary value. And then you're going to, that plus plus and minus minus, when it's at the end of a variable in Java, that means it's going to, once you're done with that operation, you move forward one. And once you're done with that operation, you move backwards one. And so that's what it's just doing. It's literally just implementing what we just talked about here, which is you're going to take one character, you're going to store it, you're going to swap values, you're going to put it there, and then you're going to move forward and backwards simultaneously. Oh, perfect. Thank you. Someone just did it in JavaScript. So it looks kind of similar to Java, except these little plus plus minus minus things, which are kind of annoying if you don't use Java, are no longer there. Okay, perfect. So really quickly, I'm going to show you what we're going to do here. Why are you not letting me? Uh-ohs. Let me stop the share and see what happens here. Okay, so let me share again. So I'm going to give you all a link, and it's this link right here. And those are going to have your whiteboards. I'm going to go ahead and drop it in the chat. So I am going to go over the problem, but when you do this, what you want to do is you're going to be in different breakout rooms. And when you are you're going to be in a different breakout room, and your breakout room is going to have a number. So if you're in room number 5, you're going to go to group 5 here. And that's going to have your problem. It's also going to have a little worksheet to help you store your values or your thoughts, but basically just notes. And then once you're ready to implement your code, you're going to go to Replit. Hopefully you all made an account. And then you're going to create a new REPL. So I use Python. And you're going to go ahead and invite your teammates to your REPL by giving them this link. And what that's going to do is it's going to allow all of you to be able to write to the same Replit. I recommend one person being the driver, meaning one person is the person who types the code here. And then the rest of you, what you're going to do is tell them what the next step of the algorithm is. I find that that is a little bit easier, a little bit more organized. So I recommend doing it that way. But let's go ahead and I'm going to present this, see if it goes. Hopefully you all see this. If not, let me know. Let's go ahead and go over the problem. So your practice problem is to merge two sorted arrays. So given two sorted integer arrays, nums1 and nums2, merge both arrays together. So for an example, oh, and your output array should also be sorted. So for example, we've got 1, 2, 3 here, and then 2, 5, 6. Your output should be 1, 2, 2, 3, 5, 6. Cool. You've got 1, 4, 5, 9 here, and then 0, 2, 3, 7, 15, 29. Your output should be 0, 1, 2, 3, 4, 5, 7, 9, 15, 29. Are there any clarifying questions that you have for me before we get started? You can drop them in the chat or you can unmute yourself, either way. No clarifying questions?
I have a question.
Yeah.
For the given sorted integer arrays, are there going to be, are the values always going to be unique?
No, the values are not always going to be unique. As you can see here, we've got two duplicates here in two different arrays, but it is the case that you can receive multiple duplicates in the same array. Great question.
And so the output array is like a new array, or are we
yeah, so
the second and the first array?
Yeah, so with arrays, you have to know what the size is going to be. You can't just alter it. So you would have to create a new array with all of the elements there. So yes, sure. You need to create a new array.
Okay.
Yes, new array. Any other questions? Yeah, go ahead, Mina.
What should we do if we have an empty array?
If you have an empty array, if you have one array that's empty, then you should still return a new array, but only with the array that has the elements. If you have two empty arrays, you should return an empty array. These are great questions. Any other questions? Any other clarifying questions? Maybe about the data types themselves? Okay, I'll tell you. It is the case that you will receive negative numbers in this array. So this is a perfect case here, but you can receive negative numbers in your input. So that's something you should think about. All right, so it looks like looks like we're all good to go here. I'm going to go ahead and pass it over to Jillian, who's going to break us out into different groups. I'm going to figure out what time that is. Oh my gosh, we have more time. I didn't talk forever. We're going to give you all of the time. So we're going to give you 35 minutes.
35, got it.
Mm-hmm.
So we're gonna break out into breakout rooms. You guys can work on the problems. If you have any questions at all, there should be a like ask for help button. So feel free to hit that button if you need help or anything, or just come back to the main meeting room and we can help you out. Besides that, I think it'll put you in your breakout room automatically. And good luck, everyone, and have
Good
fun.
luck. Have fun. Okay. All right, so welcome back. It looks like a lot of you got the solution, which makes me happy. So, and it looks like quite a few of you got a working solution and then an even better solution, which makes me even more happy. But let's go ahead really quickly, for the sake of our viewers, to see what the most optimal solution is. So, the naive solution to do this, the brute force solution, remember that, is to merge the two arrays and then sort them. And as we discussed earlier, when we were talking about the run times of certain algorithms, sorting an algorithm is usually O(n) log n. But we can do it even better. We can take 2 pointers, or in this case, 3 pointers, because for the other array, and make sure that, or iterate through the array and make sure that we are inserting it into the new array in the correct order. So let's see. I'm going to actually share my iPad here. I think that's what this said, right? Yeah, okay, uno momento. Okay, hopefully you see this. So if you have something like 0, 1, 2, 3, and we have, what's a good test case? -5, I don't know, -3, and 0, 1. Okay, so the 0 or 1, 2, 3, 4, 1, 2, 3, 4. Okay, that's 8. Wow, I can't count 8 apparently. Okay, so you have a pointer right here and you have a pointer right here. And instead of just merging the two and then sorting, which is O(n) log n, you can do it even better and you can ask yourself, okay, is j less than I? It is, so let's insert I, or let's insert j and then move forward. Is j less than I, or is I less than j? I is not less than j, so we insert j and we move forward. Is I less than j? It's not, so let's go ahead and insert j and move forward. Is I less than j? It is, so then we insert I and move forward. Is I less than j? It's not, so we insert j and then move forward. And then we keep doing that until we have one merged array that's sorted. So congratulations, everyone. I'm so proud of you. Way to go. Let's go ahead and stop this share. Oh, I guess it's 12. We're done. This is what it looks like when you implement it in Python. I already showed you the answer, but what is the time complexity of this algorithm? You can drop in the chat or unmute yourself, even though I totally just showed you, but we're going to pretend that I didn't. What would be the time complexity? Oh, interesting. So Dot is correct. It is O of n plus n. And let me actually just really quickly show you why. So when you are iterating, so one answer said O of n squared, which totally makes sense why it would seem like it's O of n squared, because you're iterating twice, right? But the thing about O n squared is that when you're iterating through O n squared, you're going to one value, and then you're iterating through all the values, and then you're going to the next value, and then you're iterating through all the values. But you're not doing that here. What you're actually doing is you're doing it essentially at the same time. So you're going through all of these values once, and then you're going through all of these values. It's not like if it was O of n squared, then it would be like this. I'm at I, and then I'm going through J. And then I go here and I start over, and then I go through J. And then go here, and then I go through J. But that's not what we're doing here. We're doing one pass of I, and then we're doing one pass of J. Essentially, I know we did it at different parts. So we started at J until it reached a certain level. Then we did, then we did I. But what it breaks down to is that we went through I once, and then we went through J once. And so what that complexity is O n plus n plus m, either way. And the reason why it's not just O of n is because this data size is one size, n, and this data size is a whole other one. So we're going to use something like m. You can use whatever letter you want. It really doesn't matter. M is just a common one. But what this communicates here is that you are going through and iterating through the full length of two different arrays. So honestly, if you said O of n, that would kind of be correct too, because that represents, you're communicating that it's linear, and that is correct. But if you want to be more accurate, and I recommend being as accurate as possible, say O of n plus m. Okay, let's go back to our slides here. That is it. I'm going to go through some recommendations here. Oh no, I forgot to give you one. Okay, I'm just going to tell you verbally. If you had a good time going through these algorithms and practicing, all right, breaking stuff. If you had a great time, I recommend that you go through the website Pramp. I'm actually going to show you right now. Let's see. Oops, I think I have to. Okay. Stop. Let me give you another share here. Oops. Ugh. Darn you. Okay, here we go. Now I'm going to give you a share. Okay, so I recommend going to cramp.com. Is a great resource for practicing interviews.
Kat, I don't know if it's just me, but I can't see the screen that you're sharing.
Oh, really? What about?
Oh, there it
There it
goes.
is.
Okay.
Yay,
sorry.
thank you.
So you want to go to pramp.com. It is completely free, and you can schedule mock interviews with a peer. So it just pairs you up with anyone, and you can do a mock interview and practice your skills. Okay, and last but not least, before we end here, I do want to fulfill my promise and go over, just making sure. Okay, we got that. Go over a previous question that was asked during our lecture. Let's really quickly talk about logs. So the question was, how do we know that log 32 equals 5? So log is something that you use when you want to figure out what the exponent is of a number. So like if you have an equation where it's like 2 to the x equals 8, you use a log to figure out what this number is right here. And so when you log 32, that equals 5 because 2 to the 5 equals, sorry, there's a train and my dog howls at the train. 2 to the 5 equals 32, meaning if you multiply 2 5 times, that is 4 equals 32. In computer science, when we use log, we actually use log base 2. So log base 2 of 32 equals 5. And what does that mean? It means 2 to the 5 equals 32. Log base 2 of 8 equals 3. Why? Because 2 to the 3 equals 8. And that's when we're saying logarithmic. That's what it means. It grows logarithmically. So when we have, let's see, let's go back here. Oh, here we go. When we have something like 32 and we're saying it's logarithmic, that's because when we look at the number of operations as it grows, log of 32 equals 5, we ended up with 5 operations. And so that's what we're saying when it grows logarithmically, is that as it increases the graph, if you were to graph this, it would be log of n. That would be what would calculate the number of operations. Okay, cool. Congratulations, Dot. You are a winner. And with that, I'm going to go ahead and pass it back to Jillian, who is going to tell us about what's going on next with Women Who Code San Diego. Oops, why am I sharing that? Okay.
Yay. Thanks, Kat. Thank you for hosting another great meetup. I'm going to pause the recording again.